All right, so now we go to lesson 2 of equations, and lesson 2 of equations is going to introduce coefficients that are greater than just plus minus 1. So in this case, we've known how to deal with stuff that's addition, subtraction across an equals sign, maybe just a little bit of addition or multiplication, division, but now we're actually going to formalize that with coefficients that are not just plus minus 1. So in the previous lesson, we had learned to add or subtract things across an equals sign. And so now what if we introduce something like 4x is equal to 20? Well, you could right off the bat assume that, okay, well, 5 has to be x in order to make this 20, but here's how we can do it. If I take this statement, or the 4x equals 20, I know that if something is attached through multiplication to this x, then what is the opposite operation to multiplying? It is to divide here. So we'll have to divide both sides by 4, and therefore when we divide both sides by 4, our 4's on the left eliminate, and we're left with just x, and x is equal to 20 minus 4. In this case, 20 minus 4, or 20 divided by 4, I should say, is x equals 5. So we can take something with a coefficient that's greater than just plus minus 1 and isolate it for its variable. All right, so here's our ammo, or here's the tools we have to work with here. So our first one is we can add or subtract a number from both sides of an equation, or we can multiply and divide from both sides of an equation in a way that would allow us to isolate for x. So consider the example below. We have 2x minus 7 is equal to 3. Well, in order to get this x by itself, we're going to have to do a couple operations here. The first one is saying if there's anything attached to this x through addition or subtraction, in this case subtraction, what we have to do is we then have to say I have to add this or do the opposite operation to both sides, plus 7 to both sides. By adding 7 to both sides, what I'm doing is I'm eliminating it from the left, plus minus 7, and then I'm figuring out what it equals on the right. In this case, it is 3 plus 7, or 10. Now, I'm left with the statement here of 2x is equal to 10. And how would I handle this? Well, I know that 2 times x, or 2x, is multiplication. And the opposite of multiplication is to divide by this 2 here. So if I divide both sides by 2, I can cross out or eliminate the 2's on the left, leaving me with 10 divided by 2. Therefore, x is equal to 5. Now, they may say to verify or check off to the side here. If they ever say verify or check that this works, what we have to do is we have to go back up to our original. So above this, we could write this is the original statement. We take the original and we plug x in with brackets. There we go. So we plug in x with brackets, and therefore we would get a 3 equals 3 here. Okay, now what if there's an x on both sides? Well, here's the thing. We need to figure out how can we algebraic manipulate it so that we have all the x's on one side, all the numbers on the other, and then see if we can isolate this. So let's see how this works in an example on the next page. All right, so 9 minus 3x is equal to 5x. What we're going to do is we're going to take the x's that are on the left and move them over to the right. How are we going to do this? We're going to take a negative 3x and we're going to add 3x such that those negative 3x and positive 3x cancel out. My new total on the right-hand side for step 2 is 9 is equal to 3 plus 5 is 8x. And now I have this number on the left or the right-hand side, and I want to move it over to the other side. Well, how do I do that? I subtract both sides. And so the negative 6 and the positive 6 subtract away on the right-hand side, or they eliminate on the right-hand side, aka we ditch the 6 here, and then we have 9 minus 6 on the left-hand side, and this becomes 3. Now, 8x is 8 times x. So the opposite of multiplying is to divide by the 8 to both sides. And when we divide by 8 on both sides, this is 8 divided by 8, which is 1. And then we have 3 divided by 8 left over on the left-hand side. Now remember from our previous lesson, we can have our x on the right-hand side, exactly where we moved it to, and that's totally fine. But we can also rewrite it such that x is equal to 3/8. If we want to swap the place of x and the number on the left and right-hand sides, this is totally fine because this is more common notation where we have the variable on the left-hand side. But if you supply your answer like this, that is also totally fine. All right, now to check our understanding or check that we get the right variable here, we plug it back in for both sides in brackets. So we substitute our x. We substitute the x back in on both sides. When we substitute x on both sides, we can verify that both sides are equal. And if the left-hand side does not equal the right-hand side at the end of this, we know that when we solve for x, we did some sort of operation wrong, or it's just not a solution to the equation. All right, now what about a more complex example? Well, by more complex, what they mean is, what if we just introduce more operations at a given time? So suppose we want to solve 3 times 2x plus 5 equals 4x plus 7 minus x plus 1. Well, we've distributed in our previous unit. When we dealt with polynomials, distribution was pretty normal. We take the 3 and we divide, or we multiply it into both these terms here. And then with polynomials, we definitely had to combine like terms or add like terms in the previous section. So when we expand this out and collect like terms, on the left-hand side, we get 3 times 2x, which is 6x. 3 times 5 is 15. We combine the like terms on the right, and we get the following statement. Now, just like our previous example, we want all the x's on one side, all the numbers on the other, remembering that we want the x's to remain positive in all of this. So the way we can do that is say, we're going to eliminate the one with the small side of x's and get it to the other side such that the left-hand side or whatever side remains positive. So I take the 3x and I subtract it from both sides. That eliminates it, leaving me with 6x minus 3x, which is 3x. And now I have this 15 being added. In order to get rid of it, I have to subtract it from both sides. And so therefore, I have 3x is equal to negative 7, or 8 minus 15. And now, there's two things being multiplied together here, 3 times x. I need to divide by 3 to both sides, eliminating the 3's from the left, and leaving me with x equals negative 7 over 3. Now remember, just from the previous example, I could rewrite this in terms of negative 7 over 3 is equal to x. This would also be an appropriate way to say the solution, swapping the left and the right-hand sides, as long as we've done all the operations correctly and we keep the terms consistent to what they look like. Now, we could check this if we wanted. We could plug this number, negative 7 over 3, back into the original statement and simplify. However, I'm going to leave that as a challenge for you. So if you would like to try this and make sure that this works and that all the steps have been followed, this is a great check. All right, steps to solve equations with integer coefficients on the variable or things that are not. So I'm going to say not plus minus 1. I mean, they could be, but when we talk about integer coefficients, typically what we're going to say is that they're going to originally, at least when we originally give the statement, they won't be a plus minus 1. So in order to do this, we need to expand the brackets and combine like terms or multiply. We then need to isolate the term with the variable, divide every term by that coefficient that's on the variable, isolating just that variable, and then check, does our left-hand side equal our right-hand side given whatever x value? So let's actually see how this works here. In the following, they say solve the equation. So in these ones, we won't have to verify, but we technically could. But let's just solve in these. If I combine the like terms on the left, well, I have 6x plus 4x, which is equal to 10x. And I'm not going to put an equal sign there because we have one in the middle. Minus 8 is equal to 12. Now we have that number attached to the 10x. So I'm going to add 8, and this is going to be 10x is equal to 12 plus 8 is 20. If I take the 10 and I divide it to both sides because I know that I was multiplying that 10, now I have x is equal to 20 over 10, which is 2. Now, we could replug that back in if they said verify or check our solution, but in this case, they don't say that. So our solution is just x equals 2, and we can stop. B, I have x's on both sides of the equations. Remember, I want to keep the x term positive. So we want to take the one that's the lesser of the x's, or the smaller value of the x's, and move it to the other side. In this case, -2 is less than the 3. So I'm going to add a 2x to both sides to move the negative x's over to the left. This becomes 5x minus 6 is equal to -21. And now I have to add 6 to both sides in order to get rid of that 6. 5x is equal to -21 plus 6, which is -15. And now, because the 5 and the x are being multiplied, I need to divide both sides by 5. Therefore, x is equal to -15 over 5, which is -3. Okay, let's go down to example C here. Much like the challenge question, we're going to have to expand our brackets, simplify or combine our terms together, and then divide by the coefficient. So I'm going to take my 4 and multiply it into both brackets here. I get 4b plus 4 times 3, which is 12, plus 16 is equal to -2b minus 21. Well, what I want to do here is combine the like terms. 12 and 16 can come together on the left, giving me 4b plus 12 plus 16 is equal to 28, which is equal to -2b minus 21. And now, whatever side has the lesser of the b's, or the more negative number, I'm going to take it and move it to the other side. So we know that -2 is less than 4, so now I'm going to add 2b to both sides. To remain equal, or hold that equality, remain balanced, I add it to both sides. 4b plus 2b is 6b plus 28 is equal to -21. And now what I'm going to do is take the 28 and subtract it from both sides. Holding the equality, 6b is equal to -21 minus 28. This is -49. And so my solution in this case is going to be, I need to divide by 6 to both sides. It's being multiplied, now I divide by 6. b is equal to -49 over 6. And so in this case, we could just leave it as -49 over 6, or reduce it if possible. Okay, solve for A in our next example. We have a double expand brackets, or a double expansion. My coefficient on the right-hand side is actually a -1, meaning both signs are going to flip on the interior here. So if I expand this, I'm going to go 3 times 2a, 3 times 3b. This is equal to 6a plus 9b is equal to, I distribute this negative into the brackets, giving me -3a minus 9b plus 27. All right, they want us to solve for a here. So what we're going to do is we're going to try and get all the a's on one side and then the b's and the constant terms on the other. How I'm going to do this is I'm going to say the more negative a's are here, and so I want to add them across in order to keep a positive. If I add a's across, this is plus 3a plus 3a. If I want to move my 9b across, I have to subtract 9b, subtract 9b. So when I do all of the following operations, it's going to cancel the a's on the right, cancel the b's on the left, and my new statement is 9a is equal to -9b minus 9b is -18b, and then plus, this should be a 27 on the end here. So we'll correct that, 27. Now, if I divide both sides by this 9, because it's being multiplied to the 8, I divide both sides by 9. When I divide both sides by 9, I have a is equal to, and the 9 is actually going to divide both the 18 and the 27. So we go 18 divided by 9, or -18 divided by 9 is -2b, and 27 divided by 9 is plus 3. So there is our solution in terms of a. Okay, the you try section, let's walk you through it. So we're going to combine our like terms if possible. In this case, we have a 2x and a -3x. This becomes, on the left-hand side, -1x plus 6 is equal to -14x plus 19. Now, I know that it's more negative on the right-hand side for the x's, so I'm going to add 14x to both sides. Add 14x to both sides. This is equal to 13x plus 6 is equal to 19. Now, I have to subtract away the 6 from both sides in order to isolate the term with the x. 13x is equal to 19 minus 6 is equal to 13. And finally, I have to divide by the 13 attached to the x. If it's being multiplied to x, we do the opposite operation, and x is equal to 1. All right, now another one where we have to expand it twice. I'm going to take my 4, expand it into both terms, and my negative 2, expand it into both terms. This gives me negative 4x, or 4 times negative x, plus 8 is equal to negative 2 times the negative x is positive 2x. I'm going to erase that and do it again. Positive 2x, there we go. Negative 2 times negative 19, this is equal to positive 38. All right, now we're going to algebraically move our terms depending on which one is less. If I want to keep the x positive, I have to take the x's from the left and move them to the right. It's the more negative values, so I plus 4x plus 4x. So I'm going to be left with 8 is equal to 6x plus 38. And now I subtract away the 38. I subtract away the 38. This is going to give me 8 minus 38 is negative 30 is equal to 6x. And now 6 is being multiplied to x, so I divide it by both sides. And therefore, my x is equal to negative 30 divided by 6, or negative 5. Okay, finally, let's accomplish the challenge one. This is a lot of terms that need to be added or subtracted or expanded together. Remember, our first step is to always expand, so let's make sure we take care of this. I expand my 3 into both my 2 and my negative x, and then I expand my negative 1 into both terms on this binomial, and my 2 into both terms on the final binomial. This will be equal to 6 minus 3x minus 10 is equal to negative 8. Negative 1 times 3x is negative 3x. Negative 1 times negative 4 is positive 4. 2 times 8 is 16. And then negative 4x times 2 is negative 8x. Now, here's where we want to be really organized so we can bring all the terms together. Just like we did in the polynomials unit, or unit 3, I can underline or maybe do a squiggle under my constant terms. Squiggle, squiggle, squiggle. That implements all my, or shows all my constant terms. And then what if I do a single underline for all my x terms here? Well, here's how this helps me. On my left-hand side, the terms I can bring together are 6 minus 10, which is equal to negative 4. And the negative 3x stays because nothing can be combined on the left in terms of x's. I then go to my right-hand side. Negative 8 plus 4 is negative 4. Negative 3x, oh, we forgot a term there. Negative 8 plus 4 is negative 4. And then plus 16 is going to be equal to positive 12. And then we have negative 3x minus 8x is negative 11x. Now, where the x is more negative in this case, it's actually on the right-hand side. So we'll want to bring those to the left-hand side to make this positive. If I add 11x to both sides, this is going to be equal to negative 4 plus negative 3 plus 11 is 8x is equal to 12. And now I want to take this negative 4 from the left-hand side and add it to both sides. So as a final solution, I'm going to get 8x is equal to 16. If I know that 8's being multiplied to x, I divide it both sides by 8. And therefore, my x value is going to be 16 divided by 8, or x is equal to 2. So there would be my solution there. So the challenge one is very difficult because I have multiple expansions, then I have to combine multiple terms, and then I have to move multiple terms across the equal sign. But as long as you're taking it step by step and remember that you have to expand, combine your like terms, and then move your variables appropriately, you will get the final solution. All right, this is where you got to check your understanding. Make sure you get your practice.